It's time to learn about increasing and decreasing functions. Derivatives help us graph functions by telling us things that we often can't determine easily without them. Among other things, derivatives can help us tell where a differentiable function is increasing or decreasing. Let's start by looking at the graph of a function that's intuitively increasing, and we'll use this to define explicitly what increasing means. This graph looks increasing on the interval I, and to see why, let's pick any 2 points on the graph and join them with a line. That line slopes upward. We can move either of these points anywhere we want on the graph, and the line connecting them will always slope upward. In other words, every secant line of the graph on I slopes upward. That's what it means to be increasing on I. This, then, is our definition. An increasing function on an interval I is a function f satisfying f of a less than f of b whenever a and b are in I and a is less than b. We also have a corresponding definition for decreasing functions. Here we require that f of b be less than f of a when a is less than b. This means that every secant line of the graph of f slopes downward. Because of this connection with secant lines, there's also a nice connection with derivatives when f is differentiable. Let's look at the graph of a function, and we'll call this interval I. We can see that f is increasing on I. Now let's add the graph of f prime. We can see that f prime is positive on I. This happens because every tangent line of f on I has positive slope. This has a nice consequence, namely that every secant line of f also has positive slope. So we get this theorem. If f prime of x is greater than 0 on an interval I, then f is increasing on I. For example, let f of x equal x squared on the interval 3, 4. Since f prime of x equals 2x, and 2x is greater than 0 on 3, 4, f is increasing on 3, 4. Another example, let f of x equal x cubed on negative 1, 1. Then f prime of x is 3x squared, so f prime of x isn't greater than 0 on the interval, since it's equal to 0 when x is 0. Does this mean that f isn't increasing on the interval negative 1, 1? Let's look at the graph. You can see from this, and you can verify algebraically, that x cubed satisfies the definition of increasing on negative 1, 1. This means that while it's sufficient to show that f prime is positive on I to show that f is increasing on I, it's not necessary. So you can't prove that a function's not increasing by showing simply that f prime isn't always positive. Let's end with an exercise for you to complete and a question. The exercise is to find a function f that satisfies f prime of x greater than or equal to 0 on an interval I that's not increasing on I. The question is this: what's special about x values for which f prime of x equals 0?